Morning everybody. Here we are going to discuss the subject control systems. In this subject we have total 10 chapters. So first unit is about introduction to control system, second chapter mathematical models, third chapter about signal flow graphs and block diagram, fourth time response analysis, fifth root stability criterion, sixth root locus technique, seventh frequency response analysis, eighth Nyquist plot, ninth compensation, 10th state space analysis. So we will start with the chapter number 1, introduction to control system. What is a control systems? It is a system is a collection of objects. A system is a collection of objects or components connected together to serve an objective, or a system is a combination of components that act together to perform an objective. So what is actually control system means? It is a system in which all the components are connected together. It is a collection of objects, that is components, in which it is about to perform a specific objective. It is about to perform a specific objective in which a specific performance, it will give the output a specific objective. It is called a control system. A system is a collection of objects or components connected together to serve an objective, or a system is a combination of components that act together to perform an objective. So this is a basic definition of control systems. Now if we go through the classification of control system, what are the different types of classifications of control systems? Here it is dependence, it is depending upon the hierarchy. In first way, it is depends upon the hierarchy. It is classified as open loop control system, closed loop control system, optimal control system, adaptive control system and learning control system. Now if we go to second classification, that is the presence of human. If it is operated manually, if it is control system is operated manually, it is called manually controlled system. If it is operated automatically, then it is called as automatic control system. Now if you go to third type, it is on the depends upon the presence of feedback, in which a control system, if feedback is present or absent, then control system is classified as two different types. First one is open loop control system, second one closed loop control system. In open loop control system, feedback is not present, whereas in closed loop control system there is a presence of feedback, there is a presence of feedback signal. So it is called as closed loop control system. Now according to fourth classification, on depends upon the purpose of the system, for what purpose it is used. So on this basis, control system is classified as position, velocity control systems, process control systems, temperature control system and traffic control system. So these five types are examples in which what is the purpose of the system in which it is used. So here you can have a question in your theory exam, like define the control system and uh, explain the classification of control system. So you can see, go through these all types of control systems and classifications. Now here are some another classifications in which these all classifications can be explained in further chapters. Now first type, mainly two types are control systems are there. First main classification is open loop control system. So as the name itself suggests, it is an open loop. So there is no feedback signal in the open loop control system. Feedback signal is not present. So if you go to the definition of open loop control system, here we can see those systems in which the output has no effect on the control action that is in the input are called open loop control system. So in this open loop control system, once if we give the input, there is a specific output. So once the output is displayed, so now there is no chance to change the output, because it cannot be compared. The output, whatever we get the output, it cannot be compared with the input signal to change according to the requirement. So for example, if we required in the output session particular output, so but if we not reach the defined output, desired output, so after if we not reach the desired output, now there is no chance to change the output, because the input cannot be changed as there is no feedback signal, so here you can see in any open loop control system, the output is not compared with the reference input. So now reference input cannot be changed to get the desired output. Once if we give the input, there is a specified output, and again output cannot be changed because it cannot be compared with the reference input. Now there is no chance to change the input and output. Once the input is given, the according to the given input, the controller will give the process, and the plant will uh, process the given input and gives the output. So here, as if we said, there is no output feedback signal. Once the output is generated, so it is the final output. There is no chance to change the output again, because there is no feedback signal. Here it can be seen clearly using block diagram. Here you can see clearly using block diagram of open loop control system. So once we given the input, it is given to the controller block. In this controller block, the given input is processed. Whatever the given input signal, it will get processed, and the signal is given to the control process, that is the controller unit. From controller, it will be given to the plant, and final output will be displayed, and the finally output is displayed. Once the output is displayed, there is no chance to change the input. There is no chance to change the input. Once the output is displayed, it is the final output, and now here you can observe there is no feedback signal. But if you go to the closed loop control system, second type, it is closed loop control system. In closed loop control system, there is a presence of feedback control. There is a presence of feedback control or feedback signal, in which output can be changed. Output, we can get the desired output, as we can change the input signal, depends upon the feedback signal whatever it is given back. So if you see the examples of open loop control system, we have different types of examples, that is traffic control system, which is operated as open loop, and room heater. Here you can see the another example, room heater, and also one washing machine example was given here for as an example for open loop control system. Here these can be operated both as open and closed loop control systems. So whereas if you go to the closed loop control systems, there is a presence of feedback control, and in which output can be changed to the desired output. If whatever the output we get, in case if whatever the output we get is not meeting, is not reaching our desired output, then we can send the signal feedback to the input. So accordingly the input again it can be changed to get the desired output. So this will be continued as a loop until we get the desired output. So it is a advantage of having feedback path, so in which we can reach the desired output, actual output, to get the actual output. And as we can change the input accordingly according to the feedback path elements, or whatever the signal in the feedback we are getting back to the input signal, and we can change the input accordingly, again it will get processed, then we will get the output, desired output. So whereas that is not possible in the open loop control system, and it has advantages and disadvantages. There are also advantages and disadvantages of closed loop control system. What is the advantage? Whereas if we see about advantage, we will get the accurate output, nearly 90%, 99% accurate output we can estimate. But it is this complete circuit will become complex, it will become complex as there are feedback path elements. And if we go through a closed loop, this sometimes output cannot be accurate, and it is not complex, it is very simple path it is. So these are some disadvantages and advantages of open loop and closed loop control system. Now you can compare both open loop control system and closed loop control system. How we are going to compare both open loop control system and closed loop control system? Here we can estimate, we can the questions regarding theory part. Define control systems, classification of control systems, otherwise define open loop control system and closed loop control system. Give some examples. So using block diagram, and you it is better to explain the open loop control system and closed loop control system using block diagram and examples. Here now another question is related to comparison between open loop control system and closed loop control system. How we are going to compare these two? What is the first comparison? The open loop system are simple, as I told advantage, it is simple and economical, and whereas in closed loop control system it is a complex and costlier. And second one, they consume less power, here they consume more power. Third comparison, these are easiest to construct because less number of components required, as feedback is not present. Whereas in closed loop control system, these are not easy to construct because of more number of components required. And stability is not major problem, and stability is a major problem in closed loop control system, because it is needing more care is needed to design a stable closed loop system. And now fifth point, open loop system is inaccurate and unreliable. We cannot get the accurate output because there is no feedback. And whereas in closed loop they are more accurate and more reliable. And sixth, the changes in the output due to external disturbances are not corrected automatically, so they are more sensitive to noise and other disturbances. Now here the changes in the output due to external disturbances are corrected automatically, so they are less sensitive to noise and other disturbances. So in some cases open loop control system is advantageous, and in some cases closed loop control systems are advantage to operate. So for simple and for normal circuit, for normal operation, we can opt for open loop system, and for getting accurate point we have to go to closed loop control system. Now the feedback reduces the overall gain of the system, And the feedback in a closed loop system may lead to oscillatory response because it may overcorrect errors, thus causing oscillations of constant or changing amplitude. So these are the points which you can compare between open loop and closed loop control system. So it is like a star mark question which is more expected in the theory part exam, semester exam. Now next topic is linear versus non-linear control system, time variant versus time varying invariant control systems, and continuous data discrete data control systems. Now further topics in next lecture, in next video you can see about what is feedback actually, what are its effects, and what is feedback. With this feedback is present only in closed loop control system, it is absent in open loop control system. So this what is actually feedback, it block diagram, and what are the effects of the feedback, it will be covered in next video. Thank you.